Electric kettles are among the simplest of household appliances, and I'm quite sure that everyone has an electric kettle at home. Have you ever thought of how an electric kettle works? How long does it take to boil the water, and how does it know when to switch off on its own? Let's take a close look. I'll first give you a quick introduction of the components of the electric kettle. The lead, a coil of thick metal called heating element, and the thermostat that could switch itself off when the water reaches its boiling point. Let's look at the first question. How does the electric kettle work? When you pour water into the electric kettle and plug it into an outlet, a large electric current flows into the heating element. The resistance of the element turns the electric energy into heat. In other words, the water is heated. Every time when I'm really in the need of hot water, I would always complain that why it takes so long to boil the water. So here comes the second question. How long does a kettle take to boil the water? We can use a formula to figure this out. Let's say we are going to boil 1 liter of cold water from 10 Celsius degree to boil point, 100 Celsius degree, and the specific heat capacity of water, which is a constant value, is 4.2. The total amount of energy you need is 4.2 times 1000 grams times 90 degrees equals 378,000 joules. 378,000 joules are far more energy than you think. An energy-efficient lamp rated at 10 watts uses 10 joules of energy every second, so it would take 378,000 seconds to use as much energy as our kettle uses in a single boil. So back to the math problem. If you are using the kettle rated at 2400 watts, then the time you need to boil the water is 378,000 divided by 2400, approximately 160 seconds. So most of the time you will be able to get the hot water in 2 to 3 minutes. It could be inferred from the formula that the time you have to wait for boiling depends on the water volume. Here we use the example of a liter of water, which will take a little bit longer. If you actually want a quarter of a liter of water, you only need a quarter as much energy. If you still boil a liter of water, 3/4 of energy is wasted. Next time, if you would like to get hot water in a shorter time, just pour less water into the kettle. It also helps you to save money consumed on electricity. But remember, you still have to reach the minimum water level. Let's move on to the next question. How does the kettle know when to switch itself off? Early electric kettles came with built-in danger. It was relatively easy to switch them on, go off, and then totally forget about them. If you were lucky, when you came back a few minutes later, you'd find your kitchen filled with clouds of steam. If you were unlucky, your kettle element might burn out, blow a fuse, or even start a fire. So as I mentioned previously, there is a thermostat in the kettle which could control the switch. The basic function of a thermostat can be deduced from the name alone. The name is formed with two Greek words. Thermo means heat, and status means constant. As the name implies, a thermostat's basic function is to keep the heat constant in a given setting. The simplest one is mechanical thermostat, which is integrated into the heating element. It consists of a disk of two different metal bonded tightly together. It is also called bimetallic thermostat. The two different types of metal have dissimilar coefficients of expansion, which means that in the presence of heat, they expand at a different speed. One of them expands faster than the other as the temperature rises. Normally, the bimetallic thermostat is curved in one direction, but when the hot water reaches boiling point, the steam produced the steam produced hits the thermostat and makes it suddenly snap and flex in the opposite direction, a bit like an umbrella turning inside out in the wind. When the thermostat snaps open, it pushes a lever that trips the circuit, cuts off the electric current, and safely switches off the kettle. There are different types of thermostat. Many are based on the designs developed by English inventor John C. Taylor. The one I introduced is a mechanical one. There are also electrical thermostats, which allow water to be heated to exact temperature and maintained there by repeatedly switching current on and off. Some home appliances which have thermostat are electric iron, water cooler, and air conditioners. They all have the same feature, which is temperature control. So our three questions are all solved now. Do you understand how the kettle works? Here is a quick question to test your mastery of the mechanism of electric kettle. If you would like to use an electric kettle which is rated as 3000 watts to boil 500 milliliter water from 20 Celsius degree to boil point, how long does it take?